Hi everyone, I'm Nithin and welcome back to PSLE Science, and today I'll be going through energy. So let's get started, okay? So for the first segment of this video, I'll be going through the 6 forms of energy, okay? So let's get started. Okay, the 6 forms of energy. First, we have potential energy, and in this potential energy, we have actually 3 other forms, which are basically gravitational potential energy, and I'm going to use abbreviations like GPE so that I can discuss easily with you guys, okay? So gravitational potential energy is GPE, elastic potential energy is EPE, chemical potential energy CPE, and second, kinetic energy KE, heat energy HE, sound energy SE, and light energy is LE, and lastly, electrical energy is EE. Okay, so these are the 6 forms of energy. So let's move on. So for the second segment of this video, I'll be going through the gravitational potential energy. Okay, so this is gravitational potential energy, and gravitational potential energy is basically stored energy of an object due to its mass and height above the ground. Okay, they've used the term stored energy. So stored energy is basically potential energy. So potential energy is actually stored energy. Okay, so you need to know this. So due to its mass and height above the ground. So these are basically the factors affecting it. Okay, so let me go through the factors affecting the gravitational potential energy. So first we have mass of the object. So what is the relationship? So the greater the mass of the object, the greater the amount of gravitational potential energy possessed by the object. Okay, we have something over here. Possessed. Possessed is actually a keyword that you need to use when you're talking about when an object has energy in it. Okay, so the comparison is basically when you have a greater mass, there's a greater amount of GPE possessed by the object. Okay, so the greater the mass, the greater the amount. So the height of the object above the ground. Okay, many students actually get confused over here. So if I got one small ball here and one big ball over here, it's on a table, okay? So this is a table over here. Okay, on this table, right? And this is ground level over here. Okay, so what they actually think, right, is that the height of the object, the students have a misconception about the height of the object above the ground. They think it's basically the height of the object. The taller the object, the greater the amount of gravitational potential energy it possesses. No, but that is wrong. Actually, it shouldn't be the height of the object. It should be the height of the object above the ground, like this over here. Okay, so both of them actually have the same GPE if both of them were the same mass. Okay, and if the bigger ball was actually a greater mass than the smaller ball, the bigger ball will have a greater gravitational potential energy because they are still in the same height. Okay, so let's go through the relationship of the gravitational potential energy. The greater the height of the object above ground, okay, the greater the height of the object from the ground, the greater the amount of gravitational potential energy the object possesses. See, using the keywords again. So I hope you understood that. Now let's move on. Okay, so third, elastic potential energy. So elastic potential energy, elastic potential energy is the stored energy. Okay, again, stored energy because potential energy itself is stored energy, in a stretched or compressed object, okay, which is elastic. So stretched or compressed, which is elastic. So elastic objects like the rubber band and the spring. So these are the two things they test: rubber band and the spring. And sometimes they also test on the balloon, because many students get tricked by this, and I'll explain later. Okay, so two factors affecting elastic potential energy. Okay, how much the elastic object is stretched or compressed. So this is the first one. So the more the stretched or compressed the elastic object is, the greater the amount of elastic potential energy the object possesses. Okay, so this is actually pretty easy to understand, so I hope you guys understand. So basically the relationship is, when it's more stretched or more compressed, the elastic object actually has greater amount of EPE. Okay, and possesses, again, keywords. Next, the second one is basically the stiffness of the elastic object. So let's go through the relationship. I think most of you don't understand yet. So when both the stiffer and less stiff elastic objects are stretched or compressed to the same length, the stiffer elastic object would possess a greater amount of elastic potential energy. Okay, so basically stiffer and less stiff, stretched or compressed to the same length, the stiffer elastic object will actually possess a greater amount of elastic potential energy. And some of you people will think, how do I find the stiffer object? So basically, how to find the stiffer object, stiffer elastic object is basically, right, so if this one has a 100-gram weight on it, and if this one also have a 100-gram weight on it, the one which stretches less is the one that is the one that has a stiff, is the one that is stiffer. So this is basically stiffer, okay, while this is less stiff. So the one which stretches more or compresses more is basically the one that stretches less and compresses less with the same weight on it is basically the stiffer one. Okay, so you can see right over here, both of them are having 100 grams, but this stretches lesser than this over here, so this is the stiffer one. Okay, so I hope you understood that. So now let's move on. So we need to take note that an object that is neither stretched nor compressed, meaning it's just at its original length without doing anything, will not possess elastic potential energy. So it does not have EPE. Okay, so take note. Okay, so I think you understood this. And now moving on to the balloon. How does the balloon affect? So the balloon, right, when it's deflated, right, is something like that. Okay, so this is a deflated balloon, but when the balloon is inflated, right, it actually, the rubber surrounding actually stretches, right, because of the air actually stretching it out. So this is why it's an elastic object as well. So it actually stretches, that's why. Okay, so I hope you understood that. So now let's move on. Okay, so for the fourth segment, I'm going to go through the chemical potential energy. Okay, chemical potential energy is one of the easiest to know. Okay, so chemical potential energy is basically the form of potential energy possessed by food, batteries, and fuels. Okay, fuels like wood and fossil fuels. Okay, food, batteries, and fuels. Okay, so this is also a form of potential energy. Okay, so you need to take note that in the exam, you are only needed to know the sources of chemical potential energy. You need to recognize the source of chemical potential energy in order to identify the correct energy conversion. So you just need to know sources of potential energy. Okay, so now let's move on. So for the first segment of this video, I'm going to go through the types of potential energy in objects. Okay, so what are the types of potential energy in objects? So first, for gravitational potential energy, water stored behind a dam, ball on top of a ramp, hanging object from the string, a rock on cliff. So basically a ball on top of a ramp, hanging object from a string, and a rock on a cliff. Okay, and also water stored behind a dam. So if this is a dam, the water is here, okay? And then this is the sea. Okay, why is this so? Why do all of this actually have gravitational potential energy? Because objects that are above the ground actually possess gravitational potential energy, and the ones that are on the ground actually do not possess. Okay, next, elastic potential energy. A stretched or twisted rubber band, stretched or compressed spring, bent diving board, and an inflated balloon. So I already explained to you the inflated balloon. So all of these are actually examples of elastic potential energy. Next, chemical potential energy. These are the sources, okay, like wood, fossil fuels. These two are actually the fuels part, okay, because you can burn wood, right? Food and batteries. Okay, so I hope you understood this. Now let's move on. Okay, for the sixth segment of this video, I'm going to go through kinetic energy. Okay, so this is kinetic energy. So kinetic energy is basically the energy possessed by an object when it is moving. Okay, when it is moving, so moving objects, the amount of kinetic energy possessed actually depends on its mass and speed. So these are the factors. So let's go through that. So the two factors affecting kinetic energy is basically the mass of the object. So let me give you an example for this. So let's take a look at the relationship first. When two objects are moving at the same speed, the one with a greater mass would possess more kinetic energy than the other. Okay, so if I have a truck over here, okay, and I have a car over here, okay, and I have a car and a truck over here, they are moving at 60 km per hour, okay, both of them. But you know that the truck is maybe let's say the truck is 500 kilo or something like that, and the car is 100 kg. Okay, this is not actual. I'm just giving some random example for this. Okay, so the one with the greater mass actually has a greater kinetic energy, so it possesses more kinetic energy than the other. Same speed, so a factor is that it must be at the same speed. Okay, so if the car is moving faster than the truck, but the truck is still at 60 km per hour, we can't determine which one has a greater kinetic energy, because two factors are already changed, so that there are two variables changed, and in the primary school syllabus there's only one variable changed, so we can't actually do anything about that. So this is one scenario that I can show you, and I hope you understood it. Now let's move on to the second factor, which is the speed of the object. So when two objects have the same mass, okay, let me draw two cars over here, and this is another car. When two objects have the same mass, the one that travels at a faster speed will possess more kinetic energy. So this car is 60 km per hour and this car is 100 km per hour. So car A or car B has more kinetic energy. Car B, right? Because it has a faster speed than the other one. So car B actually possesses more kinetic energy. So this is basically the two factors affecting kinetic energy, and you hope you understood that. And I hope you understood that. Yeah. So now let's move on. So let's take a look at the kinetic energy template answers. So for template answer 1, let's take a look at it. So this template answer is for when an object bounces, rolls, swings back to a lower height. Rolls or swings back to a lower height. Okay? So when the object bounces, so you're throwing the object over here. So the ball is being thrown and then it's going over here. This is the second height. That's going back down. It's going up. Third height. Going back down, coming back up. Fourth height. So you see that is gradually decreasing, right? So this is basically to a lower height. Object bounces to a lower height. Okay, this over here, the ball actually rolls, and when it comes back, after it rolls here, right, when it comes back, it actually does not reach point A again. It actually reaches a lower height than point A. So this is basically when it rolls back to a lower height. Next, swings back to a lower height. So this is a pendulum. So when object A from here, it goes to C, then when it swings back, it will be around here. It won't go back to point A. So it swings back to a lower height. So these are just some mere examples. Now let's take a look at the template answer. So step 1, we need to write down the kinetic energy template answer. So which is basically some of the kinetic energy of the object is converted to heat energy and sound energy due to the friction between surface A and surface B. Okay? So it's converted to heat and sound energy because of the friction between surface A and B. So if the ball is bouncing, right, the friction between the ball and the ground causes heat and sound. Okay? Next, step 2, we need to link back to the question. Thus, the object will possess less kinetic energy, which is converted back to gravitational potential energy, causing it to reach a lower height. So when less kinetic energy is converted to gravitational potential energy, is actually converted to less gravitational potential energy than the one that is converted to at the start. So from this height, when it goes down, because of the friction, it loses some kinetic energy, and thus when it goes back up, when the energy is converted, it's actually converted to less gravitational potential energy. So I hope you understood that. Now let's move on to the second template answer. Okay, so this is the second template answer. So basically, it's based on a moving object slows down. So you see this over here? When this ball, if you push it, it's really fast, and then when it goes to the end, it starts to slow down, and yeah, it starts to slow down over here. Slows down. Okay? So I need to know this. Come on. So first, for step 1, what we need to know is basically the kinetic template answer again. So it's the same template answer. Some of the kinetic energy of the object is converted to heat and sound energy due to the friction between surface A and surface B. Okay? It's the same template answer. And then step 2, we link back to why the object slows down. So, thus the object will possess less kinetic energy and move slower. There's no energy conversion here, right? Because the object is moving, it's still kinetic energy. Okay? So come on. Now let's move on to the next template answer. So I hope you understood template 1 and template 2, and this is the last template 3, which is still related to template answer 2, which is basically on the moving object basically coming to a stop. So on the same table, if there was something blocking the object, the object will actually hit this thing. So the ball actually slows down, and when it's slowing down, right, at the end it hits this thing, it actually stops. Okay, so this is basically when an object comes to a stop. So first we give the same template answer for step 1. So in this case, it's not some of the kinetic energy. In this case, it's all of the kinetic energy because it came to a stop. So all of the kinetic energy of the object is converted to heat and sound energy due to the friction between surface A and surface B, like this table and this thing as well. Okay? Next, link back. Thus, the object will no longer possess any kinetic energy and comes to a stop. Okay, so I hope you understood that. Now let's move on. Okay, now for the 6th segment of this video, I'll be going through, will the ball possess kinetic energy at the highest point at X? Okay, so will the ball possess kinetic energy at the highest point at X? So there are 3 scenarios. One when the ball is swinging, one when I throw the ball up, and second when the ball is flying. Okay, if you throw the ball horizontally. Okay, next. So for the first one, at point X, the ball is at the highest point. So this is point X, highest point, and does not possess kinetic energy as it is not moving. So basically the energy conversion is that all the kinetic energy of the ball has been converted to gravitational potential energy. So there's no kinetic energy, and you know that kinetic energy is basically movement, right? And there is no movement. That's why it does not possess any kinetic energy. So for second one, at point X, the ball reaches its highest point after being thrown upwards and does not possess kinetic energy as it is not moving. So you know when you throw the ball upwards, right? There's a split second that it stays there and it comes back down. So that split second is basically when all the kinetic energy is converted to gravitational potential energy of the ball, and thus it is not moving and it is at its highest point. Okay, so it does not possess kinetic energy at point X. And for the third one, okay, so this is a little bit tricky. Since you thought X, and for the first and second one, there is a lot of there's all the energy is being converted to gravitational potential energy, right? So you might think that all the energy is being converted to, all the kinetic energy is being converted to gravitational potential energy at this point, but actually that is wrong, because the ball is at its highest point, but it still possesses kinetic energy as it is still moving forward, because the ball is going in this way, not this, or not just this and stays there. It's going from up to down. So it's actually moving in the same, it's still moving, okay? So as long as the ball is still moving, it will continue to possess kinetic energy before it falls down. Okay? So I hope you understood that. Now let's move on. Yeah, now let's move on. Yeah. So for the 7th segment of this video, I'll be going through the 2-step energy conversion answering technique. Okay, so the 2 steps. For the first step, you need to state the factor affecting the energy form. So this energy conversion technique is basically for energy conversion questions. Okay, so energy conversion questions. So for step 1, you need to state the factor. I went through many factors affecting the energy form, right? And all the energy forms that I went through which had factors affecting them is the one that will be tested in exams, okay? And write the energy conversion. So you need to write, so all the kinetic energy has been converted to gravitational potential energy, something like that, okay? So I hope you understood that. Now let's move on to a real life example, so that we can apply this technique, okay? So this is the example for the last segment of this video. Okay, so for this question, how does increasing the number of books the number of blocks below the ramp affect the speed at which the ball rolls down. So if you increase the number of blocks over here and the ball actually rolls down, right? So this is the ramp over here. So how does it affect the speed at which the ball rolls down? Okay, so for this is basically gravitational potential energy. At the start, the ball is at gravitational potential energy, right? And all of this is basically kinetic energy. So it's gravitational potential energy to kinetic energy. So say the factor affecting the energy form is basically the height of the object above the ground. So when more blocks are added, the ramp's height increases, allowing the ball to be at a greater height above the ground. So this is the factor affecting the energy form. Step 2, write the energy conversion. Basically, thus the ball will possess more gravitational potential energy, like I said, which is converted to more kinetic energy to roll down the ramp at a faster speed. Okay, you can realize that I'm using comparative words because they are talking about increasing the number of blocks. So I need to use comparative words when there's more at a faster speed. See, more, faster, increases. Okay, so all of these are comparative words. So I hope you understood what I've explained for this question and everything that I've explained for energy, and I do hope you have truly understood what I've taught you today. And thank you and bye bye. I'll see you in my next video. Bye.